beginning of the video. Okay, today we're going to do a lab over ocean acidification. It involves a little bit of chemistry. That's probably backwards. But basically we're going to show what happens when the ocean dissolves carbon dioxide inside of it, kind of like a soda. So that gas goes into the ocean when humans emit it into the air. So this is our chemical formula. That's backwards for you, but it's sodium bicarbonate, which is baking soda. So we have that here, regular baking soda, plus vinegar, which is acetic acid. We're going to mix those two things together, and those two reactants are going to make several products. Sodium acetate, which is a salt, which we don't care about today, and some water, which we don't care about today. But it's also going to make carbon dioxide gas. See some bubbles form in our cup as we do the experiment. So some chemistry today to retrieve that carbon dioxide from the air. This is my assistant. She's going to help me today. She's going to do the brunt work. So we have 2 cups here. Both cups have the same thing. They have a little bit of bromothymol blue, BTB. Let's just call it that from now on because that's easier. That's a color changing solution, and it's going to change depending on the pH of the water. I don't have the strip in front of me, but you can see that on the lab. So it's blue now because it is basic. It's around a pH of 8 or 9, and that will change if our pH changes. So I've already prepared that. That's in both of our cups. This is the normal ocean that's not acidified, and this is going to be our experimental cup that we're going to infuse carbon dioxide into. So we're going to do that chemical reaction. We need baking soda. We need 2 grams. So
how are you going to get a gram?
How are you going to get a gram? We're going to use the balance. Okay, so we need to put our paper cup on there, which is already is there, but you need to zero out and you need to subtract the cup. So press that 0 button, please.
I know how to do it.
Okay, now it says 0, so we can weigh out 2 grams, please, and keep that in the cup. Almost perfect. Over. Take a little bit out. It's always best to be conservative.
Okay.
1.9, I think that's close enough.
Yeah.
Unless you're a perfectionist.
There you go.
Perfect. You got to be patient. And what we're going to do...
How does baking soda taste?
Don't eat anything from the lab.
It's baking soda.
But I think technically you can like brush your teeth with it. I don't think it's too toxic. But we're going to place this in our experimental cup, and we're going to make sure that it doesn't touch the bottom. But we want the lip of the cup, the top, to be under the surface but not touching the water because we want to capture the carbon dioxide gas that's coming out.
That makes sense.
All right, and now we're going to add our second ingredient, which is the acetic acid, the vinegar, because we want to catch those carbon dioxide bubbles. So we added the baking soda. Now we need to add the second reactant, which is the vinegar, and we need 6 milliliters. So we're going to do it the brunt force way. I think we should both do this at the same time because we want to do this fast. Okay, these are 3 milliliter pipettes. So if we suck it up to that top line, that's 3 milliliters. Okay, so you suck some up and I'm going to suck some up. Okay.
It doesn't make any sense. Like how much?
Up to the 3 milliliter line. So, or as close as we can get. Okay, and we're gonna put the top over this one. Obviously nothing's being captured in there, but that's our control, so we don't want to do anything to it anyways to overload the balance.
No.
Okay, so we're gonna add this to the cup, and as soon as we add the vinegar, that carbon dioxide, when I say go, add it, that carbon dioxide is gonna start to be formed, and we're gonna capture it in the cup with this lid. Ready, 1, 2, 3. Okay, we want to capture the gas. We see bubbling. You don't think it worked? You got to be patient again. We see the bubbles. That means there's gas being dissolved in the cup. It's going to take a little while. The reaction is going to happen at the very surface. So we have to get down and look at the surface of our cup and
It's
hopefully.
so far away. How are they supposed to see this?
Yeah, we'll zoom in. I'm waiting. It might take a little while for diffusion to happen. And it's easiest also if we put a white background here. And it's okay, some things in science aren't overly dramatic. Some things are subtle.
Ew.
And some things we have to wait for. So, still waiting. Do you see it turning yellow at the surface? I might be hallucinating. I don't see it. I'm gonna mix it up a little bit. And the best thing we can do is compare it to the control. So again, I might be hallucinating, but it looks like this one's less blue than that one, does it?
Maybe.
Maybe? Let's give it some time because diffusion takes a little while. This one's looking more like a teal to me, and that one's more blue. That's why we have a control, because if we didn't have the control, we wouldn't be able to see, like, we wouldn't remember what it looked like. It looks like it's turning to me. Let's put this paper behind. Kara, can you get it closer, please? That way they can see. There you go. Aim it down a little bit. So the color's definitely gone down. Definitely. It's not super dramatic. Well, I mean, in person, it actually is pretty dramatic. It's definitely turning yellow now. It takes a little bit of time. But even a small drop in pH in the ocean is a big deal. And in the next experiment, we're going to see how that low pH, that acidity, can affect creatures with a calcium carbonate shell, like corals, which are one of the most biodiverse places on Earth. So that video will also be posted. Still turning yellow, definitely much more dramatic now. That's very satisfying. What do you think, Kara?
Yeah.
I'm gonna have to clip this into a short, I'm sure. Okay.
Ow!